So first, thank you for the organizers for having us. It's a big honor to be here, standing here today. So thank you. I'm Omer. This is Ishai, who's sitting there. And today we want to talk about dynamic security testing. How to run it in the CI, what does it mean, and could it be easy and simple? And I want to start with a story. And like any good security session, the story about Equifax. How many of you have heard about Equifax? Not surprising. So I'm not going to ask who heard about Equifax breach, because I guess it's all the people. But in case you didn't hear it, so Equifax breach was pretty minor breach, you can say. Only 143 million US customers affected. You know, not so big one, not big effect. And like any good breach, it contains first name, last name, a lot of information. The breach happened in July and only disclosed in September. And you can guess that it has some effect on Equifax breach. Yeah, you can see this nice drop here. Now, you might be thinking that this breach happened because of some sophisticated zero-day, but actually no. It happened because of a very simple reason. Equifax used a library called Struts, and this library has non-vulnerability, and they didn't patch it. So the hacker exploited this library and were able to hack into Equifax. And if we take a deeper look into this vulnerability, so this is the details of the vulnerability. And the interesting thing to notice, the first is the severity, 10 out of 10, which should indicate how serious it is. And the second is the date. It disclosed at March, and the breach was at July. They had 4 full months to patch this library, and they didn't. Now, why I'm telling you this story? What is my point here? I don't want to blame Equifax or do some shaming to them. It really doesn't helpful. I think what we should take from this story is ask ourselves, can we be the next Equifax? Is this something that could happen to us? Who here thinks their company could be the next Equifax? Okay, good to hear that it's not only us. And this is basically what you should take from this story. This is something that could happen to anyone. And we should all ask, what can we do? Which activities we could adopt into our development lifecycle in order not to be the next Equifax? And I'm saying that because this is basically what I'm doing at my work as the security department at Soluto. And I'm doing it for the last 3 years. So there are many things that you can do, like threat modeling, design or code review, bug bounties, and of course, security testing. So this is what we are going to focus about today, how we can build security tests and how we can run it in the CI, and how we can create security tests that give us really high value, that are simple to integrate, and they are free. So this is what we are going to see. And before that, security test, if regular tests like unit or integration going to check your code for bugs, so security test will test your code for non-vulnerabilities. This is the high-level idea. And now I want to invite Ishai to talk about one of Soluto projects, why it's so critical and how we added a security test to it. So Ishai.
Great. So I'm Ishai. I'm a tech lead at Soluto, and I'm working on an infrastructure backend project, and I'm going to share how we added security tests to one of our most critical project, which is called Tweek. I'm going to describe Tweek shortly, so you'll have the right context. So Tweek is a feature management solution, and for those of you who are wondering what's feature management, basically a feature management solution allows us to control the behavior of the feature remotely. And I'll show it by example. Let's say we have an e-commerce app and we have an item listing page, and we want to create a new design for the app to see if it results with better engagement from our users. So we create an additional version which is light and with different color scheme. And right now what we are going to do is provide several of our users with the first version and the other users with the right version. And for that, Tweek can help us because we can use a Tweek to define that 50% of the users will get the dark variant and 50% will get the light variant. and the app query Tweek whenever user get into the app, to the store app, and get the right variant. Another use case we use it is for feature flags. Let's say we have a new feature like the rating, and we want to open it gradually only to subset of our users. So we can use Tweek to define, let's open it to 30% of the users that live in Israel. And that's pretty much it. That's the editor, and we have API for that. And the reason we decided to do security testing in Tweek is because Tweek is very, very critical for us. We use it everywhere. Every new service use Tweek, and every new app, and query it every time. So it's super mission critical for us, and we must keep it secure. Another reason is that Tweek is an open source solution, and in open source solution, security can be more challenging because all the code of Tweek is available, publicly available on the internet, and we need to make sure that there's no vulnerability. We can't obscure our security in Tweek, and also it affects not only us but other companies that use Tweek as well. So that makes it more challenging. Another reason is that in an open source project, we can have code changes from external contributors. So how do we protect our master branch in Tweek? We use a regular GitHub flow. I'm sure many of you are familiar with that. I mean, it's pretty common. And our main master branch is protected. And if you want to add new code to Tweek, you have to do it using a pull request. And our pull request approval mechanism is requiring a manual code review from one of Tweek maintainers and a bunch of automation check. The first automation check is pretty common. It's just an integration test. It's what we see here with CodeFresh. The second suite of tests, unit integration tests check the quality of our product, and there are not any bugs and stuff like that. And the second check is version I, which is rather interesting. That's actually the first security tool we integrated into our CI. And it checks that all our dependencies are up to date and they does not have a security vulnerability or serious security vulnerability. Really nice project. And I mean, that can help us prevent an issue like we saw, like Omer showed before with Equifax. So it's really useful, but it's not enough because it's only check for third-party issues in third-party packages or libraries, but it does not provide us a security guarantee against the actual code changes in the PR. So with that thought of mind that we need to add additional security layer, I went to our security department, which is basically Omer, and asked him, Omer, how can we add security checks to Tweek? So, all yours.
Thank you, Ishai. So basically I say to Ishai, there is a saying, and I'm pretty sure all of you are familiar with that saying, the best defense is a good offense. And we can apply the same saying to testing. To security testing. If we could just take a hacking tool and run it in the CI, it will give us the best protection in the world because we could take real-world hacking tool that hackers use to hack our system, Tweek, and run it on each new commit. And by that, we could make sure that new code we are adding is secure and continue to be secure. So let's put our hoodies on. I'm going to now show how we can use this hacking tool to hack Tweek, and then Ishai will show how we can take this hacking tool and run it in the CI. So let's start hacking. This tool is called OWASP Zap, or just Zap. It's a tool developed and maintained by OWASP, Open Web Application Security Project, if you're not familiar with. It's a non-profit organization and try to improve the overall security of software development. This is a bit high-level overview of Zap from OpenHub. You can see a lot of information here. The main thing to take from here is that Zap is free and open source, highly active, highly maintained, highly popular. And now I'm going to explain what does it mean that it's a hacking tool, how you can use it to hack things. This is how Zap UI look like when you open it. You can see that we have big attack button, which is what you would expect from a hacking tool. And Zap has two modes. You can use Zap in two modes to hack things, the passive and the active mode. So now we're going to go through each one of them. So let's start hack Tweek, and before we start, we need to do a quick overview of what we're going to hack. So this is a high-level overview of Tweek architecture. Ishai already show parts of the editor, but Tweek also has API that application or services can use to query and get the relevant value for a feature. And it has some internal things like database and Git and other microservices. Today we are going to focus about the API and the editor, hack them, and then protect them in the CI. So now let's actually start, and we're going to start with the passive mode. In the passive mode, Zap acts as a proxy, web proxy. Web proxy is something that you put between the client and the server, for example, between your browser and your server, serving the web page. And when Zap acts as a web proxy, it can inspect all the requests and response from your client to your server. He can take a look at each one of them and run passive scan rule. Passive scan rule is a code that tries to look on the request or on the response and looks for issues. For example, headers that indicate security issues or missing headers that indicate issues. And it's really simple to write. I write one passive scan rule, so I know that it's simple. And there are already many existing. You can take out the full list later, but I just named a few to give a feeling of what it's already able to check. So I will stop to questions in a few more slides if you have any. So the first thing we need to do if I want to attack Tweek in the passive mode is to set up my computer to send all the traffic to Zap in a proxy mode. This is how you can do it on Mac, but it's really, really common. You can do it on any OS in a similar manner. And then we can move to manual assessment. The step of manual assessment is you need to try and cover as much pages of the web application or of the API with curl or any other thing. This is basically Tweek editor. Ishai showed this part, but this is how the menu look like. So in this step, we need to cover as much as possible, so Zap will have good assessment. And when I decided that I cover enough from the application, I can go to Zap and look on the results, on the various alerts. And you can see that we have many things here that indicate potential security vulnerabilities. So now we need to go and check each one of them and decide if it's really issue that we need to fix or if it is some false positive. Because like any other automated tool, it has some false positive. So let's talk about, look at this one. So this is the response, and Zap thinks there is an issue with this header. So you might think, okay, why there is an issue here? You can try to think about it, why it could be indicating an error. But actually, we don't need to think. Zap can tell us why it's an issue. The server leaks some information through this header about the stack we're using. We have data description here. We even have a solution. Zap can tell us how to fix it. And we have some reference here to blog posts or other pages you can go and look to learn why it's a problem. And this is a pretty cool feature of Zap that not always exists. Zap not only tell you what the problem is, it can also help you fix it. So this is something that is not so common with security tools or the security community at all. I don't know how many of you had interaction with security guys, but they're pretty good at finding issues, but will not always guide you on how to fix it. And then either you will not fix it well, or you will not fix it at all, because you will not know how. So this was the passive mode. Now let's talk a bit about active mode, which is a bit more interesting. In the active mode, we need to start when Zap already know all the relevant URLs or endpoints in our application or API. So we can do it with the manual assessment like I did before or in any other way. And then we can tell Zap to run active scan rule. Active scan rule is a bit different from the passive one because it's actually going to change the request and create malicious requests from the original request. Zap has already list of existing many known attacks. And like before, there are many more than the one I listed here. And he can take your original request and create attacks like the one described here to check if your server can protect itself from those attacks. So this is the active scan work. Now, I said that the first part is to get all the relevant endpoints. We have a nice trick for APIs. There is something called OpenAPI or Swagger, which I guess you already heard about. It's a way to describe in JSON all the endpoint in your API. You can see that we have the endpoint here and the parameters and the type of each parameter, really descriptive. And we can give it to Zap. By giving it to Zap, you can see that now Zap knows all the relevant endpoint in our API. and it also knows the parameters like described in the Swagger. So now we can do the nice, click on the nice button of attack, this one here, and Zap will start attacking our API. So let's do it. Let's press this red button. When you do it in real world, it's going to take some time, between 5 to 10 minutes. So it's usually a good time to take some coffee break or something like that. But when Zap will finish, the first thing you can notice, I'm not sure if you can see, but it's the number of the requests, 40,000 requests, which is a lot of requests. And this is why it took so much time. And like before, we can do the same thing. We can go over all the alerts and check each one, decide if it's false positive or not. See the details, it's really the same scan from before, but this time from the active scan. What's nice to look at is the error. Zap was able to create a request that caused error on Tweek that was not handled by the API. So this is something to take into consideration when using the active mode. Don't run it on production unless you really know what you're doing. It could cause errors. So this was the active mode. Now, you might be thinking that it's really cool, but will Zap be able to protect us from real-world issues, from vulnerabilities that were used in a real world against web application? And to answer this question, I want to show you this table. This is a report from HackerOne. HackerOne is a bug bounty. It's basically a place where you can pay to attackers or security researchers to find vulnerabilities in your application, like Uber, but for hackers. And they generate reports. This is a report for 2017. And this is based on the statistic from the vulnerabilities reported via HackerOne. And it's divided by industry, it's this row, and by type. And I put this here because I marked all the vulnerabilities that Zap is able to find. So you can see that most of the big ones are detected actually by Zap. And some of the things that I didn't mark also could be detected by Zap, but it needs some more configuration. So to answer this question, yes, Zap can find real-world issues that other applications were hacked through. So this was how we can use Zap to hack Tweek. Any questions about the hacking?
So Zap's running on a dev or staging deployed environment with your database and everything else also?
Yeah, so yes, you can usually it's better to run Zap against dev or staging. Not good idea to run it on production because it might cause side effects.
But passive is okay to run?
Yeah, passive doesn't do anything actively.
It's a chaos monkey.
Do you use it as with an API, part of your CI/CD?
So yes, this is the next part of how we can use it in the API. This is what Isha is going to show just in a minute.
Local software.
Okay.
And how do you get all the time the new vulnerabilities? Also from the open source?
Yeah, so all the vulnerabilities are the active or the passive scan rules. And you can contribute your own scan rules if you need something that already not covered. Again, I did it, so I know it's pretty simple. And it keeps getting updated.
There is an option to download.
Yeah, Zap as an update mechanism, I can show it to you later. Last question?
Do you have to run the manual? Like use the URLs?
So for the active scan you're asking. Yeah, for the active scan you need to have all the URLs. You can do it either with Swagger or through the manual assessment like I did. The passive is based on the manual assessment. He look on the request you are doing and look for. Yeah, you can do the manual before the active. You can do that or either use the Swagger one. Okay. So now let's move to the second part, which take this hacking tool and run it in the CI. So Ishai.
So Omer showed us how to hack Tweek, but obviously done it manually with Zap UI, and we're going to do the same thing, just automatically. So let's see how we can do it. The first thing, as Omer mentioned, Zap has two modes, passive and active. So we are going to do each one separately. I'll start with the passive mode. So that's Tweek architecture, as Omer mentioned before. And when Omer hacked Tweek using passive mode, he went to the editor and do a common user scenarios. And the same go with the API, just use curl or postman or something like that. So the first thing we need to do is generate some traffic to proxy through Zap. luckily for us, we're already doing it because we have automation test. We have a UI automation test that check our editor for all the common scenarios, assuming our coverage is good enough. And the same go for the API. We have integration tests that check that the API work properly. So basically, the only thing we need to do is just put Zap in the middle as a proxy between our test and the actual services. So how are we going to do this setup in our CI? So we are going to use Docker. I'm pretty sure this is DevOpsDays, so probably you heard Docker quite a lot. So Tweek is designed as a multi-container app. Each microservice of Tweek, and there are a couple of other microservices that are only available in the backend, have official Docker image. And our CI is completely Docker native. It's just run Docker there. And also our test suites are Docker processes. So it's really easy, and the good thing about Zap is that it has an official Docker image. So we can just use the Docker image of Zap. We don't care if it's written in Java or whatever. It's just Docker. So everything is containerized, and how can we set up this? We are going to use Docker Compose. Docker Compose is a YAML format for describing multiple services. We can use it to run Docker locally, all these services, and each service corresponds to a container. And you can see that we have a service definition for the UI test and service definition for the editor. And what I'm going to do is just add a new service definition for Zap based on the Zap image, and add an HTTP proxy for our UI test. Assuming our UI test acknowledges HTTP proxy, that's all the work we need to do to proxy our session data through Zap. And all of that is run with Docker Compose app, really simple. And the nice thing about Docker Compose is that it really can run anywhere. You can run it on a developer machine, whether it's Windows or Mac. You can run it in various CI, and even in production, you can run it on your favorite orchestrator. In the future, you can even run it on Kubernetes, so it's really easy. And we are now running in the CI using Docker Compose. We have these tests that are proxies through Zap. And the only thing we need to do is extract the result from Zap. We are going to use a Zap REST API for that, and you can see that we'll get a pretty JSON version of the same UI that Omer shown before. This is an alert, and we have the description, risk level, solution, reference, and all of that. Really simple. And we can use curl, which is my favorite way to do it, but also there's a CLI and various SDK because Zap is really popular. You can use SDK for PHP, Node, Java, .NET, whatever you wish. Okay, so we have this security data test, and we can extract this data, but the problem that we have many false positives. As any automation tool, and probably a security automation tool as well, we have a lot of issues that we need to ignore. So how can we do it? We are going to use additional OWASP tool that is called Glue. And Glue, like its name implied, is designed to add, to glue security tools to your CI. It supports various security tools. I mentioned there's 3 of them, static analysis tools and Zap use here, but it supports additional tools. It provides us with a uniform way to filter all the issues and alerts from the various security tools. And there's also a mechanism for reporting, so we can say that issue that is critical will be reported to our Jira tracker or GitHub issue or whatever we want, or if we want to add integration to our TeamCity or whatever CI tool. And everything about it is free and open source. We can extend it, we can add our custom filters or custom reporters, and it's really, really nice. So we're going to add some glue to our CI, and that's the only thing we need to do. We are going to run it with using Ruby. The task is Zap. And notice here that we provided with a glue JSON file. That's the configuration that in this file we can define what the filters that we want to run on the result of Zap. So let's look at the Tweek finding. We found out through Zap that we have insecure cookies. And we fix it because it's a real issue. We have missing security headers, which is also a real issue, and we fix it. And we have insecure hash, but it's not really an issue. We are using SHA-1, but we're not using it in an area that is affecting our security. So we just need to ignore it. And for that, we are going to define it in our glue JSON format that I showed before. And you can see that we have the tool, the URL that it found the issue, and the name of the issue, and we are going to ignore it. The nice thing about it is that we cannot just ignore it, we can also postpone issues. Let's say, for example, we have an issue that is not really critical, but we don't want it to be ignored forever. So we can say we are going to postpone it for a couple of months or whatever, and fix it later. So really, really flexible and easy. And that's basically the passive mode. The active mode it's much easier because as Omer showed before, we just took a Swagger file and clicked on big attack button. Naturally, the same click of a button we can do with a CLI. So we are using the Docker image of Zap. We provide it with the right Swagger file, and we attack Tweek. And it's going to nuke our API with 10,000 of requests. And we can apply afterward the same glue mechanism to filter our active scan result. So probably the first question we do need to ask is whether it actually works. So let's see, for example, we have a pull request that is done by Omer to Tweek regarding our UI experience. It's not the prettiest thing in Tweek, the login UI. And Omer suggested to add some color to it, so it won't be that ugly. So that's Omer PR. He did some changes. We can see he had the color red. And I think I'm going to approve it. Anyone think I shouldn't approve it? Okay, so yeah, let's continue. And I also compliment Omer on his great choice of colors. And we can see that I approve the change, but our test failed. And why should our test fail for something so simple as changing a color? Let's check the CodeFresh output, and we can see that we have alerts from Zap. Omer did change the configuration of the cookie, so Zap found new issues. You can see it here. And well, nice try, Omer, but yeah, our protection actually works. So that's great. And I invite Omer to conclude this session. Okay.
So thank you, Ishai. I guess I should try it harder next time. So to conclude what we showed today, basically we showed two ways to integrate Zap into the CI, the passive and the active mode. And they both were pretty simple to integrate, thanks to Docker. And also they both give us wide coverage of our existing application. But there are also some differences between them. The first difference is that the passive was pretty fast. It did not add any significant time to our CI, where the active was pretty slow, as I showed when I talked about how we can hack Tweek with it. The second difference is that the passive mixed two types of tests. You probably noticed it when Ishai talked about the malicious commit, that he had to go into the build log to understand if it failed because of the integration test or because of the security test. The active was only dedicated, it was dedicated type of test because it didn't rely upon the existing test. For Tweek, we decided to use only the passive for now, mainly because of the performance issue. We didn't want to affect the build time, but we're still thinking about what we can do with the active because the active is highly valuable. Maybe we'll run it once in the night or something like that. We're still talking about it. And if I go back now to how we started this session with Equifax, I do hope that now you can see how you can add security tests to your CI that give you really high value, that are simple to integrate, and what is also very important, that are free, not cost you any money, just use it. And in case you're thinking that all the things we show here today are relevant only if you're using GitHub, if you're using open source and GitHub Flow, so no, it doesn't matter what is your CI, whether it's GitLab, Bitbucket or Subversion, TFS, whatever. It could be on-prem or on the cloud, and it doesn't matter what is your CI, whether it's TeamCity, Jenkins, or Travis, or again, any other CI. You can use it anywhere. The only thing you need is Docker, and Docker is quite common today, so It's make it platform agnostic, and thanks to Glue, you can also tailor the reports to what you need. You can create issues on Utrecht or on Microsoft Teams. So again, whatever you need, it's really flexible. So I do hope that you ask yourself, how can you use it? How can you add Zap into your CI? And there are some reference links that we created for you, except from those slides. And the first link is the pull request at Tweek. This is my pull request of adding this solution to Tweek, so you can check out the commits and see what we did there. There is also the malicious pull request, the one that Isha showed, so you can feel how the output from Zap look like. And there is also a sample repo that I created. In this sample repo, I use vulnerable app called JuiceShop. And I added this solution to this app, so it's easier to learn from it because it's a lot more simpler than Tweek. And there is also a blog post describing all the technical details required to get it. So you can find all on my Twitter account. I had some technical issue that I tried to resolve, but I put it on my Twitter account right after the session. So thank you. You're invited to come to talk with each one of us, or we can continue the discussion now with the open space. We would love to help you set it up, so feel free to come to talk with us or tweet to us. We would love to help you set it up. I really enjoy doing it. I think Isha also enjoyed it. So thank you again for listening.